To add our images into our processing projects, we want to save them into a format that is usable by processing. Typically, all of the web formats are PNGs, GIFs, and JPEGs. I'll be encouraging PNGs for most of the projects that we work on. So I've saved this background image out. It's in the dimensions of my project. And that is going to be important that we create artwork at the size that we want to use it in our processing projects. Now, if I jump over to my processing project and take a look at that, we will see that now we are looking at the catcher game as it was left. So we completed adding the bomb object last time, and our to-do now today revolves around images. We'll specify two kinds, static images and add animated images. So these two types of images that we want to add into our project. So the first thing that we need to do is we need to set it up so that we have a way to reference the image file. And what we're going to do is create a variable to hold that information, and then we will load the image inside our setup, and then we'll tell that image to display in the appropriate function so that it paints in the background image while we are playing the game. So to do that, what we first have to do is to set up our image. So I'll just make a section in my variables here. Images are of a type of P image. So capital P, capital I, image. And now we specify which image. And now I will set it up as my background image. An important thing to do when we're working with images is that we want to load the image once, and then we can tell it to draw as many times as we want. If we load the image, say we have an image for our drop objects. If we load that image inside the drop class, every time we add a drop, we're loading an additional copy of that image. Eventually we can run out of memory, so that's not good. And if we load the image and tell the image to show up in our display function, we'll find our program very quickly comes to a crawl and will eventually crash as it runs out of memory. So loading images is something we should do once, and then we can tell images to display as many times as we want as we work through our project. And I'll just work on the images up here at the top so that it's easy to see what we're working on. So background image is going to be equal to load image. And now we specify the name of the file. And now that name of the file, the name of the file is going to be what we saved it as when we created it. Now, we put our images inside a data folder. Processing prefers that we do it that way. That's the proper way. It also helps to keep our project organized. If we just put the images in the data folder, we don't have to specify data in the path name of the file. If we do, it still works, but we don't have to. If we have subfolders within our data folder, so we have a folder for each type of asset that we're working with, and when we have animated assets that can become an issue, then we can start specifying path names here as well. But otherwise, if we just match up the file name to the file name, we're going to be good to go. So now I've loaded that background image. The next step is now I want to tell that image to show up on screen. So I only want that background image to show up on screen while I'm playing the game. So that would make sense to put it in my play game. I mean, I could make it show up. I could have a separate background image for each of my game states, a win background, a lose background, which would be nice. That would be a preferred way of doing it. But for our example here, I'm just going to put it into our main project here. So now under play game, with that, we have a couple of options here. Now if we notice, we call clear background inside of play game. But if I look at my different other game states, so we also call clear background here. So if we did just load our image inside of clear background, it would populate our entire game. So this is slightly redundant because that was moving whole chunks of code over, so we don't really need that here. We can say we're wiping the background. But now, if I want to show that image inside my game as my game is playing, we use the image command. So I specify what image I want to see, and I will list my background image, and I give it a location of where I want it to be positioned on screen. So that's important because when we load an image for, say, our catcher or the drop object, instead of using 0, 0, we will be using X and Y values. So inside of catcher, eventually, instead of drawing an ellipse, we will say image, the catcher image, comma, comma, and then X and Y. Same thing for the drop objects. Instead of using ellipse, we'll say image, drop image, comma X, comma Y, and then that will draw them at the correct location. So now that I've specified I want to see this background image show up inside of play game, we can run this and see how it plays out. And we can see now I have that background image. It doesn't work really well with these blue drops because they kind of blend into the background. So that now means I may want to think about adding some artwork for my drops and my catcher objects. To work on adding in individual sprite artworks, I've set it up at 32 by 32 pixels to match the size that we're working with on the catcher. Now, the background, when I look through this in Photoshop, we have different options. And one of the things I want to make sure I check is the transparent background. If I'm going to be bringing this in, it's either going to be a 32 by 32 pixel box, or if I want to make my artwork so that it's more interesting in its silhouette, then we set up a transparent background. Now I hit create, we get our window, we get the ubiquitous checkerboard in Photoshop that shows us that it's small as we're working with it. Now, to add in artwork, I can see that if I work with a standard brush, and we got to adjust some of the sizes. Typically when I'm working this small, I'm going to want to use a much harder brush so we get hard edges occurring within it. That yellow is really not pretty. Also, we'll probably want to turn off a few of the visible things here. So under view, under show, turn off the pixel grid so it's a little bit cleaner. Because when I've zoomed way in on something, I'm at 700% or even 800, so we can zoom in because I'm working small. Probably need to clean up what we're working on. Now, to produce my artwork, I'm going to actually go with a bright edge. Just maybe not that bright to start with for so I'm going to just build a basic spaceship. But if I give it a bright edge to begin with, the nice part is then when I fill this in with whatever color I choose, no, it's going to be in the reds. Now as I fill this in and want to mark it up, we can get that contrast, but it will have the glowing edge as part of this spaceship. So then that will give it a bit of a glow as it works its way. So it's going to be small. Now, one of the key things to work with on here is, as we do this, we're using circle-based collision. We will be probably migrating into rectangle-based collision, so then you think about your artwork and how it fills that shape. Doing pixel-based collision, where we take into account the details of the object and all of its contours, gets to be a little bit trickier when we're trying to figure out how to get things to work, and it can also be much harder in terms of performance, that if you're using true pixel-based or outline collision detection, that can be a much costlier process to work with. So now at 100%, that's about what my spaceship will look like, but when it's on a dark colored background, then it's going to have the glowing yellow edge. So with this, now that I have created it, we can save it out, use the export legacy. Now, it's small enough I could probably do this as a ping 8. If we go to a ping 24, we can see that the file size goes from 1.9 up to 2.05, but on ping 24 we're going to get a little cleaner artwork occurring with it. So now if we save this out into the data folder, I'll just save this out as ship, and now it's been saved. Jumping over into processing, now we need to add in a new variable, pimage ship, and repeat the process. Ship is equal to load image ship.png, and now inside the catcher object, if we look here, we have our ellipse statement. We're no longer going to use that, and instead image, which image? We want to load the ship, and now we need to say where we want to draw it. Now, ellipses by default are using, they start drawing from the center of the object. The image will draw from the top left corner. So to keep our current collision detection system working, we need to offset our position. So it would be x minus r. R is half of the width of the object, and y minus r, again, half of the height of the object, because we do have a square image that we are effectively working with. And this now will draw that ellipse at the, or draw the image at the center. Because by default, if it's drawing from the center, if we now, or the image draws from the top left corner, but now if we move over half and move up half, that now is going to put the center of the object where it was previously. And to see that that's happening, we can leave that previous ellipse there. I'm going to choose a really bright color so we can see if it's happening. So we'll leave that previous ellipse, and now if we run it, and we can see how it's perfectly centered. Where if we just do X and Y and run it, we'll see where that problem occurs. We can see how where the catcher was versus if I hold my mouse still, you can see I'm pretty much pinned to that top left corner of that ship. So by using the minus R, which is really the width and the half of the width and half of the height of the object, it lines it up. So now we don't need to see that green. Now, it's kind of fun with the green. It's almost like there's a shield around it. I'll do a transparent one. So you can see there's this little green glow. There's the ship moving around. So we now have 2 images within our program. Adobe Animate, previously referred to as Adobe Flash, can be a useful tool for creating animated sprites because it has a timeline built into it, and it's a nicer timeline than trying to build animated sprites in something like Photoshop. So if I'm going to do this, we can create a new project. Now, as we're going to create these projects, we have a bunch of different forms that we can choose as different types and styles. It doesn't matter too much what we choose. And as we go to build our artwork, we have a couple of things that we could think about. Currently, the canvas starts out at 550 by 400 in size. We could shrink that to our finished default size, or we could try to draw small and fit our artwork within this, because one thing that Animate will allow us to do is to export at the pixel dimensions of the artwork that we're working with, so we can set it up that way. But if we know that we're really good about staying within the drawing within the borders per se, we could even shrink it down, or at least use that as a guide. So I'm going to knock my project down to 32 by 32 as I set this up. Now, as we've done that, we'll probably want to zoom in to build our content. And the nice part about working in Adobe Animate is it does give pressure support as you are working with drawing tablets if you do that, so you can make thin and thick lines. And it has just a nice level of kind of correction of lines as you work and build that up. So with this, I am going to have just trying to fit within a very tiny space here as I create my space unicorn. So there's the start of the unicorn. He's going to need a tail. He's going to be wiggling his legs as he moves through. What's useful as we work, when we are working inside of Animate, we do have an option that we can turn on what's called onion skinning. That allows us to see what's on our frames. Now, to advance to my next frame and to be able to create artwork within it, I can redraw my artwork on each frame, which then gives me kind of a shaky line style animation if I'm not really smooth with my hand, or I can duplicate the frame and then modify it. Both are viable options. So if I decide I want to redraw it, I have pressed the function key F7. That gives me a new empty keyframe. Now I'm going to create my next layer of artwork. And if we continue this process, I can hit F7 again, so now it once more shows me what is happening with my artwork. I find it's useful to create the outline first and then to work on filling it in afterward. Because if I fill in and make each frame perfect first, it's harder to build that animation. Now I'm grabbing the playback head and just dragging it back and forth. So you can see I go from frame 1, 2, 3. Now what would be nice is to turn that kind of into a loop so that if it's going to repeat as part of it, I can option drag that frame over, and now we can see if I turn off onion skinning, turn on looping, and hit play, we'll see that I have a very spastic animation happening. And part of that happening is because each one of these drawings is only showing up for a single frame, which makes it really, really fast as we look at it. So what we probably need to do is to space it out and make each one of these show up on screen for a little bit longer, and that will certainly smooth out the animation. But before I do that, I'm going to work on just completing the animation as we look at it. I'm going to get rid of this white background color so it's easier to see when I have now painted, so I've modified the stage background color. The next thing that I want to do is to fill in the color of the body, and then I'll paint in the tail, and then we'll extend the frames out. Now to fill in, I can grab the paint bucket tool, go and choose a new color, and I can now just move through my frames, coloring it in. So now we can see. I do want to go clean up this horn here a little bit. It got a little skinny there. So now it's time to paint in the tail. We don't have a lot of room to work here as I paint in the tail, so I'm going to be have to be careful as I do it. Now we could potentially grab the rainbow fill color, and as I do that, we can see that's not really working because it wants to work within a larger area. So what we'll probably do is just cycle through and go red, orange, yellow, green, blue, and maybe violet for it. So I will want to turn back on onion skinning as I work through this so I can kind of think about the tail and putting it here. So red, orange, yellow, green, blue, violet. So that's now the first frame of the tail. Now as we can work with it again, and what I will do is, because the second frame and the fourth frame are the same, once I've completed the second frame, I'll just copy that and replace what's on the fourth so it cleans up. So what I'm trying to do is to be a little bit more efficient with my color usage. So I'm going to just paint all the colors once we don't have to keep changing color. And go grab I've used the eyedropper to go back and get my blue. I think I have enough here that I don't need onion skinning. And add in. Now, one thing you'll notice is my artwork doesn't fill the entire frame as it moves through. So that potentially could be problematic for hit detection if we're using a straight rectangle shape hit collection, because as it moves through, we can see that there's gaps, and that is something that is always problematic when you are designing artwork. If you look at old school video games, they made sure that the artwork filled the screen correctly. So as I paste this in, what I want to use is paste in place, so that not just paste and then that will keep it where it's supposed to go. If we turn back on looping, hit play, we can see that now we have our very spastic unicorn that's going to be falling from space. To make this a little bit better, what we can do is we can extend this out, and I'm clicking on a keyframe and then I'm adding in additional keyframes using the function key F5, and when I do that, it now spaces it out so we have a little smoother movement occurring within the animation. So a couple things to notice here is my artwork does fit neatly within a single frame or a single size. So as I want to export this out, it's not extending out beyond the 32, so that should give me a good size to work with here. The way to get out of here, there's a lot of options that we can choose: export movie, export video. We also can put it into movie clip and then export what's called a sprite sheet, so all the images are part of one file. We will look at that weeks from now and see how that part works. Export video requires us to use Adobe Media Encoder. Export movie is the easiest way to do it because then it's PNG sequence. Choose that. We'll have transparent background occurring within the project. So now I'm just going to go here, and then in the data folder, I'm going to just make a new folder to keep things organized. I'll hit create, and it's going to now produce for me an image sequence. And now when we look at the options, we want to make sure that we're choosing 32-bit. That allows us to have transparency. It's exporting it out at 32 by 32 pixels. So if you made your artwork really small on a large canvas, this method does not work. This only works if you made the canvas the size of your finished artwork, so you don't have a lot of wasted pixels, because we will be using that pixel dimension as a way of detecting for hit detection and everything else. Now we hit export, and when we jump over and look at the folder inside of data, we will see there are my different unicorn images, and we can see as it cycles through each one of the frames. So we're in good shape there. The next step is to utilize that image sequence inside our catcher game. This is going to allow us to create animated images. So I can now move this, add static images to my completed file there. Now we need to add in our animated images as well. And something else we can add in is we'll look at rectangle hit detection as well and work on adding that into the project. So our next step is to add in our animated images. Animated images, what we need to do is we need to have all of those images stored in memory, and to do that we need to have an array of images. So going down here, what we're going to do is set up an array that holds those images, and then we can now display each one of those image frames. So this will be an array that holds p-image, but we specify it's going to be an array because we have all of those unicorn images that we're working with. And my array, I will call it unicorn images. So now we need to figure out how to populate that array. And the way that we can do that is to say unicorn images is equal to a new p image array that contains, and this is where I need to now know how many were contained, and it was 12. I have 12 frames, so I can now specify that. So now we have unicorn images is prepped and ready to be populated with content. So for int I is equal to 0, I is less than, in this case, I is going to be less than 12, I plus plus. And this is where we get to fill it up by saying unicorn images bracket I is going to be equal to load image. So it's very much the same, except now how we load it is going to be a little bit different. And this is where it's, oh, sorry, I'm thinking of something else. Now the name on this, as we look at it, we have to format it a little bit. And this is where we're going to use something that processing has built into it, and it's a number formatter or a string formatter that allows us to, well, it's a number formatter that we will format the number so it creates the correct string, remembering that we're trying to create 4 numbers long. So to set this up, we need to remember the full path. We put the unicorn images in a folder called unicorn, and now we need to add to it our number formatting of I, because we need to set it up so that it doesn't just show I being 0 through 11, but we need to make it to I needs to become 1 through 12, and then we want it to be 4 numbers long, 0001, 0002, 0011. So we have to set that up. Then we also need to add into it the file extension, the .png. And now as we set that up, that populates all of our unicorn images. So we've populated the unicorn images array with a bunch of images. If I go into the drop, we can just say image unicorn images and specify which one. I will just start out by grabbing the first one and then draw at X and Y. So if we do this, theoretically, the unicorn should be drawing itself, and we can see, whoop, got to avoid the bomb. We can see the unicorn's doing it, but we have to use the same thing we did of offsetting the position. So offsetting, in this case, by R, or we made it 32, so it's actually offset by 16 and offset by 16. So now I'm going to put the ellipse on top because otherwise the unicorn will cover it. So we'll just put that here, run the program, and verify that this is working. We can see that the circle is on top of the unicorn. So now we know that part works. We can get rid of that extra junk. The next thing is to figure out how do we animate this sprite. So what we have to do is now we're going to be modifying the drop class, because our main game, now we've loaded the images, but the main program doesn't care about how those unicorns are animating. The drop cares about how it's animating. So it doesn't want to just show us the first frame every time. It wants to show us one of those 12 pieces of artwork. So this is where we now need to set up the frames that we're working with. And then after we do that, then what we can do is choose which frame we want to see at any given point. To keep track of that, we need to, inside our drop class, we need to have a couple more properties. We need an int, which is going to be our frames, how many frames are present, and then we will have an int, which is going to be our current frame. And then we will be able to cycle through those. So our current frame will start out at 0. That means, which in this, it's such a short sequence and it's so fast, you would never know if you started out at 0 or any of the other frames. But if you had, say, a longer animation and you wanted things to start at random points within that so they didn't all appear to be the same, then you could set current frame equal to a random, but you'd probably want to then set, it'd be a random based on the number of frames. And then our frames, we know, is 12 because we have our 12 images that we're working with. So now that we have set up our current frame and then we know our total number of frames as we have populated that, we are able to then figure out how to modify and update which frame we are showing. So the current, or the easiest way of going about that is we can say if what we do is we say current frame go up by 1 if current frame is equal to the total number of frames, then current frame is going to be reset to 0. So the current frame goes up if current frame is maxed out. We reset it to 0. And then instead of showing us frame 0, we want to look at current frame. And now we can see that we have our little wiggling unicorns falling from the sky.